All right, thank you for joining us today. And in this video, we are going to practice, right? And I have a nice question that we are going to go through together, right? So let's jump right in. So we have set A, set B, and set C, and we want to prove that A intercept B is equal to what? C. Now, the idea of proving or prove that this is the same is like the idea of what we started, right? When I said if we want to prove that something is equal to, we need to show that if A intercept B belongs to C and C also belongs to A intercept B, then we can say that A intercept B is the same as C, right? So that's what we are going to do. Now, if the question was saying that show, then we can pick some integers, numbers, we list them, and then we show it. But since this one is proof, then we need to prove that the function is the same, right? So now let's go through the process, right? So what we are going to do is now to prove that A intercept B is equal to C, we need to show that we need to show that one, A intercept B belongs to C, and two, C also belongs to A intercept what? B. If these two conditions are true, then we can say that yes, indeed, you know, A intercept B is equal to C. And one thing about this one is saying prove that. So it means that definitely it is true, right? Good. So let's try and then go through. So first I'll start with for for I want to start with for C belonging to A intercept B, right? So what does this mean? So here we want to prove that every element in C is also in A intercept what? B. Or let me say A and B, so right? Remember, intercept is the same as n, right? So we want to show that every element in C is also in A and B. And the reason why we are using A and B is that if I have 2 in C and it's also in A and B, then since 2 is in A and B, then A intercept B is 2 and then C is 2. So C belongs to what? A intercept B. So that is the idea. That's what we want to look at it, right? So for us to do that, first we need to show that we want to show that for C in A. So for us to show that um, C is in what? A intercept B, then first C should be in A, and we also need to show that C is in B before we can conclude that okay, C is A intercept B, right? So as I said, if C is 2 and A is 2, and we also show that C is 2 and B is 2, then A intercept B will be 2 and A and C will belongs to A intercept B, right? So that's what we are trying to do, right? So A belongs to C, right? Now we know that from C, C was equal to 11 4 n plus 1 minus 3, and we said n belongs to an integer, right? So what we are going to do is we are going to let x to be equal to whatever is here, and then we need to solve it and get what is in A, right? So let x belongs to or let me say let x equals 11 4x plus 1 minus 3, right? So now we know that n is an integer, right? N is an integer. So since n belongs to an integer, right? Then 4n. This 4n here, we know that if n is an integer, then I multiply 4 by an integer, I need to also get an integer. So if n is an integer, then 4n is also an integer. Very nice, right? So if n is an integer, then when I multiply any integer by any scalar, I need to also get what? An integer. So this one will help us to say x is equal to 11 4k, sorry, 11k plus 1 minus 3. How did I do that? Now this 4k is replaced by the 4n here. So now I need to describe that k is equal to 4n. And remember we said 4n is an integer, right? It means that k2 is an integer because k is equal to 4n, right? So now let's try and solve it. This is going to be 11k plus 11 minus 3, and this is going to be 11k plus 8, right? Where k is an integer. So we can see that we can conclude that hence x belongs to A. How did I see that x belongs to A? This right here is the A that they give it to us. Where is A? A is 11k plus what? 8, as you can see here. So how did you do it? We picked C and we were able to show that if x belongs to this, right, we should be able to show that x belongs to this one too. And that's what we saw it from here. We picked by letting x to be equal to the element in C, right? And we were able to show that, oh, okay, indeed, the element of x is also in what? A, because this is the A. So now we've proved that C belongs to what? A. The next thing that we need to do is we need to prove that C belongs to B, right? Then we can take it from there. All right. So now let's also go for C belonging to B. Then we check how we can also manipulate that, right? So for C belonging to B, from C, we know that C is equal to 11 for n minus no plus 1 minus 3. Is it plus 1? Let me see. Yeah, plus 1 minus 3, where n belongs to an integer, right? So that's what we saw from the other equation, right? So what we are going to do is we are going to let x, the same thing, x to be equal to 4n plus 1 minus 3, right? So what can we do from here? What we can do is let's try and expand this one. When I expand it, I'm going to have 4n plus 11 minus 3, right? And this is the same as 4n plus 8. Do you see that? And then when I factor 4 out, I'll have 11n plus 2, right? 11n plus 2. Now let's look at something that I'm going to write here. Since n is an integer, right? Since n is an integer, then so if n is an integer, then when I multiply it by 11, I'll get integer. And then when I add it to 2, I'm going to get integer. So then 11n plus 2 is also an integer. And I can make that integer to be, let's say, k. right? Or any other variable that I want it to be, right? So I'm going to, let's say, if I'm choosing um, this one to be equal to m, then I will just get it there. So my x, this implies that x is equal to 4m, right? If I choose 4m, then I'm describing it as 11n plus 2 is equal to m. Or let me put it this way, m is equal to 11n plus 2, right? And we are saying that m is an integer. So we need to choose m in a such a way that becomes integer. So now everything that I'm doing, I need to do it in a such a way that I get, so this one we are moving from C to B, right? So as we were doing, you said when you pick the left, your guide is the right. So here I was going to B. Why did I get to B? Because I know that B is what? 4m. So I need to manipulate it in a such a way that I get what? 4m. When you look at this one, I started from A, I started from C, I was going to A. So my main motive is start from this and get here, right? So anytime I'm solving it, I need to choose my K and my M and my function in such a way that at the end of the day, I need to arrive at A. The same thing that we did here. And we were able to also show that this is an integer and this is the same as what? The B function, which is here, 4m. So what will be the conclusion? We can conclude that hence x belongs to what? B. So now that we've shown that x belongs to B, then we can conclude that since every element in C is in both A and B, it follows that C belongs to A intercept B. Good. So now we were able to show that okay, x is in what? C, but x is in C is also in A, is also in what? B. Do you get it? So the idea is now we are saying that C has element of x, A also have an element of x, and B also has an element of x. Now what is A intercept B? A intercept B is x. So you can see that definitely the element in x is also belonging to this. So that was the assumption that we were making to prove that. So this is just one side. This is just this. We've just proved that C belongs to A intercept what? B. The next step is to prove that A intercept B is also in what? C. If we're able to do that, then now we can complete the what? The proof. So now let's take the next one that we will do. Now let's check for the other one. So for A intercept B in C, we need to prove that or show that every element in A intercept B is also in C. Is also in C. So the same thing. What we need to do is we need to assume that we have X element in any of the functions, and then we work with it to get to C. So here we are going to start by saying that assume, or let me say, let X belongs to A intercept B, right? Now the main concept here is if X belongs to A intercept B, then we are saying that X is X in what? In both A and B, right? Because if A intercept B and X is in between or is in A intercept B, then X should be in A and X should be in what? B, before we can conclude that, okay, that is true, right? So what we are going to do is we are going to pick it from, let's say, A. We do it in such a way that we get through B and then we need to get to C. So that's what you are going to do from here, and it's going to be nice. So let's see what I'm going to do here. I'll say X belongs to, or X is equal to, or let me say let S to be equal to 11k plus 8. Now what is 11k plus 8? Let's go back to the question. 11k plus 8 is actually the what? The A, right? Good. So now we want to pass through these two before we get to this. So now what can we do here? As soon as we are saying that this is equal to this, remember k is an what? Integer. K is an integer. So the next thing that we need to do is we need to make sure that we pass through when x is also equal to b, because the idea is that we are saying that x is in A intercept B, x is in A, x is in B. It means that x is equal to this and x is also equal to the B function or anything that was given. So here we are saying that k belongs to an integer and x also belongs to, or x is also equal to 4m. How did I see that? This is the 4m is the B function. And then the B function, we are saying that x here is in A, also in B. And it means that they are the same. So here too, we are saying that m belongs to an integer. So we've gotten two of them. So since x is equal to this and x is also equal to this, now since x is equal to this and x is also equal to this, what can we do here? We can say that this implies that 11k plus 8 is equal to 4m. So this is what you are going to have. So now the next thing is for us to manipulate it to get what? C. Good. What can we do? This one is the same as 11k is equal to 4m minus 8. But the idea is that we need to look at what we are going. Where are we going? We are going to here. We want to arrive at this place. This is where we are getting to, at C. Okay, so now since we have that in mind, then we can continue. Now we can see that this one we are going to use a little bit of abstract and those kind of thing here. Now we can see that 11 and 4 are co-prime, right? I mean, like, this is the multiple of 11 is a multiple of k, and 4 is also a multiple of 11, like multiple of 11, multiple of 4, right? So 11 and 4 are co-prime, right? So it means that k must be a multiple of 4. Like, this k here should be a multiple of 4, right? So that it can suit what we are looking for here, right? So we are saying that since 11 and 4 are co-prime, then k must be a multiple of 4. It must be a multiple of 4. So if that is the case, then we are going to let k to be equal to 4 times n. We are getting here. Don't forget this. This is where we are getting to. So you see that in the equation we have got 11k, and we are letting k to be equal to 4n, so that we will come somewhere here. So that is the idea. So now k is equal to this. So when I put it inside where n belongs to integer, so when I do the substitution here, this is going to be x is equal to 11 4n plus 8. This is right here, from here, from this side. So let me show you where I was taking it from. I was taking it from here. So now, since I saw that if I do something like this, 11 and 4 are co-prime and k must be a multiple of 4, then I will choose my k to be something that will be a multiple of 4, and then I'll plug it in here. So when I do the direct substitution there, that's what I'm going to get from there. Then what can I do again? I want to make sure I get something like this. Let me just copy this one here so that you will know how I'm going to do the multiplication for us to get what here. So the idea is that I want to get this. Let me paste it here. I want to get this here. Now I've gotten this here. Now you can see that this is like 11 4n plus 1. So it means that I need plus 1 here. So what I'm going to do is, this one can be written as 11 4n plus 11. I'm putting plus 11 here so that it's like you having a b plus a, so that I can factor the a out and it will be left with b plus 1. So that's what I want to do here. But if I add 11 here, you see that I'm changing the question. What is here? What is here is what? 8. So for me to get 80, I need to subtract what? 3. And you can see that the minus 3 is also showing here. So now when I factor 11 out, I'm going to have 11. What will be left here is 4m. Then when I factor this one out, it will be left to be 1. Then I have this. So now you can see that there we have the C. So what can we conclude? We can say hence X also belongs to what? C. So what can we say? Thus every element in A intercept B is in C. So A intercept B belongs to what? C. So now I'll put the conclusion here. Therefore, since C belongs to A intercept B, and A intercept B also belongs to C, we have A intercept B equals to C. So that's what you're going to have. So let me just go through very quick for you to get the understanding. Now we wanted to prove that A intercept B is equal to C. What did we do? First, we said for us to prove that this is the same, first we need to make sure that every element in A intercept C is in C, and every element in C is also in what? B. If we don't do that, it can be possible that we have all the elements in B, A intercept B in this, but we don't have all the elements in C in this. So what we need to do is we need to make sure that every element here is in C and C2 is in this. So I started by proving this one. Then I said we want to make sure this belongs to this, right? Now this here means that we want to prove that every element in C is also in A and B, right? The idea is that if the element in A is in element in C is in A and element in C is in B, then we can find the A intercept B, as I explained. So now first pick X belongs to A. The idea is that now we are going to pick C function and we need to get to what? A function, as we were doing. So pick the left and I need to get to the right. So we picked this one, we manipulated it, and we were able to get what? The A. And we said, okay, so if this X here belongs to the C function and we have manipulated it for us to see that x also belongs to the a function, then what are we going to say? We are saying that x belongs to a. That's what we did. Then we want to do the same thing for c. We pick the c function, we're able to manipulate it to get the what? The b function. Then we said, okay, x also belongs to b. And we were able to conclude that, okay, then all the elements in c are also in what? A intercept b. Then the last one that we needed to do is we need to also show that A intercept B is also in what? C, right? By saying that, okay, if X belongs to A intercept B, then X is in A, X is in B. So it means that every element in A is the same as every element in B. So that's the reason why we equated them. And then we went ahead to find out that 11 and 4 are cofactors. So I need to have my k to be a multiple of what? 4. Now I chose that one because I saw that moving to my c, which that is my right hand side, I need 11. That's the reason why I said, okay, k should be the multiple of what? 4. Now let's assume that my left hand side for C here was 4. Then I will say that since 11 and 4 are co-prime, K must be a multiple of 11. Do you get it? So that I can get the function there. So like you are playing along with the equations in a such a way that you are going to get what is on the right, but in the right procedure, right? So we did that, we came to do the substitution, and we saw that yes, indeed, A intercept B is the same as C. Thank you and see you in the next video.